Hello and welcome to today's webinar, Secure SD-Wan Architecture Overview. Before we begin, there are a few housekeeping items to keep in mind. If you have any questions during today's webinar, please enter those questions at any time in the Ask a Question box below. We will monitor these questions throughout our webinar and answer them at the end of the webinar. You can also download the slides at any time from today's broadcast by clicking on the Attachments tab below. This webinar is being recorded and will be available to view on demand immediately following today's live broadcast. Now, let's get started. My name is Michael Wood, CMO with Versa Networks. I'm joined today by Kumar Mehta, Founder and Chief Development Officer for Versa Networks. Welcome to today's live broadcast, Kumar. It's great to have you here.
It's great to be here, Mike, and thank you for the introduction. Good morning. Hope you and your family are doing well and staying safe in this era. Thank you for joining our Secure SD-Wan Architecture Overview. This webinar and subsequent webinars are purely educational and informational, and I hope you enjoy it. With that, let us dive in. This specific slide is all about how complex we made our branch architecture. But before that, I want to give you a little bit of a historical perspective, Mike. How did we end up in this complex architecture? It all starts with a bright engineer who comes up with a great idea to solve a pain point of that vintage. And he or she builds a company around that idea. So the world ended up with a WAN optimization solution, a next-gen firewall / UTM solution, an SD-WAN solution, an LTE solution, etc., etc. You get the gist. Fast forward to today, and this has resulted into complex branch network that you see here. The IT person is afraid to change the architecture because it is somewhat working, though at an immense cost of complexity, Mike, and inefficiency. What is really needed is much more simplified architecture, which is CapEx and OpEx efficient. And that is really going to be of paramount importance in this post-COVID era. If you look at this architecture, Mike, you can see there are multiple WAN devices to manage. That means you have to also learn multiple management system. It is also every one of these code bases are different. So the attack surfaces for them are different, and hence the security compliance issues come up. It's very hard to make this architecture highly security compliant. It consumes more space and power. It results in poor performance. Much of it will get you in the next slide, Mike, and results in slow change and multiple management systems to learn. Any other input, Mike, you would like to give to this slide?
Well, Kumar, it's interesting because you and I have been in this area, in the networking space, for probably more time than we'd like to admit, but this is really the way that the branch office network and branch wide area networking has, I would say, transpired over time. It's almost this expansion of capabilities where maybe one started with the router and then brought in WAN optimization. Obviously, security as connectivity back to the internet occurred. Those devices began to proliferate, and then SD-WAN came on the scene, and those devices began to be deployed. So this is, certainly more of a traditional or legacy, as you say, implementation model. And I'm sure there's a lot of challenges that are produced with this model, but this is kind of the reality of a lot of our branch offices, right, Kumar?
Absolutely, Mike. And it's you're forever chasing network issues in this kind of network, and you really want some sanity and simplicity in your network. So with that, I'm going to kind of show why the performance impact is there in this specific network. So I'm going to go to the next slide and kind of go through a sample packet walkthrough of each and every one of these appliance or device and see what all functions they go through. And in the end, things will be amply clear on why it is inefficient. So here's a packet which comes through the switch and goes to the WAN optimization device. Then the WAN optimization device goes through, it gets the packet from the wire, it parses the packet, does some quality of service, does some TCP optimization. Then it goes to the SD-Wan device, which essentially does its own set of getting the packet from the wire, parsing the packet, do route lookup, do DPI, do traffic steering, and then it goes to the WAN router. And there you get the gist. It's going to be the same set of functions which are in red, repeated again and again. Mike, what that boils down to is 60% of the functions which each and every one of these branches, each and every one of these branch appliance does are repeated over and over again. Clearly, this is a very inefficient way of solving a problem, and this results into latency, it results into complexity, and it results into higher cost. Mike.
So Kumar, a couple of things that jump out at me with this is that, one, the packets as they flow in and out of this particular branch or maybe a data center or campus location, they're going through each one of these devices, whether they like it or not. It seems like, and each device has got to actually touch those packets. And what I'm seeing here jump out at me, Kumar, is that what you're describing is some things that are somewhat redundant. They happen again and again and again at each one of the devices within this network topology. Is that right?
Absolutely, Mike. 60% of the functions which are done by every one of these devices are the same, and therein lies the inefficiency. Additionally, Mike, what happens is every one of this code or software is independently developed, and that means you got to worry about security compliance of every one of this code, and it just is it has a huge amount of attack surface. It opens up for the outside attacker to come in and hack into your network, Mike.
Well, and okay. Kumar, one of the interesting things here is that this almost is the origination of a lot of the architectures we see out there for SD-WAN. They just come from a different starting point, don't they? It'd be interesting to kind of look at the different architectures that exist for SD-WAN implementations and designs to sort of understand the comparison there.
Absolutely, Mike. That's a great segue into my next slide, where essentially you have different vendors who started from a different starting point and then added SD-WAN to it. For example, let's look at the router-based model here. Maybe you do not have separate hardware devices here, but SD-WAN, WAN optimization, advanced security are all running as separate independent virtual machines or containers in this solution, each again doing the same 60% of the functions which we just spoke about in the previous slide, resulting in complexity, lower performance, latency, and jitter. So that's just the router guys. That's just the first set of people here who entered into the SD-WAN space.
Yeah, and you described with the router model that maybe it's a virtualized software instance that's doing some of these functions, but I've even seen router-based architectures where there's, for example, security, there's a separate module, a physical hardware module that's actually running the next-gen firewall or IPS or UTM functionality. Have you seen that also? Same thing with WAN optimization too, now that I look at this diagram.
I am so glad you brought that up. A lot of folks, they basically have power-sucking blades, which they put in the chassis. But each and every one of those power-sucking blades run a separate software, which is completely independent and unknown of the packet going through, let's say, an SD-WAN software versus security software, and they still repeat the same functions which we spoke about. So clearly, maybe they unify it at the GUI layer, but they still are running independently, still the same inefficiencies. Just because you put them in a chassis with separate blade doesn't mean that they are all designed in a unified package manner. Mike, does that answer your question?
It does, and this architecture, router-based architecture, really looks a lot very similar to what you described in sort of the legacy model, where I have all these different, they're physical appliances. Maybe the router-based model I've converged those appliances or integrated them, into the router, and there's separate modules or separate software instances. But what I'm experiencing is really the same thing, where those packets, as you described, are flowing through each one of those modules separately, independently. There's a lot of duplication that's occurring, and like you've described, inefficiencies, even potential security vulnerabilities. But now, what about, there's a number of vendors that came out on the scene quite a while ago as just SD-WAN, vendors and SD-WAN based architectures. Can you talk about what those look like and how those fit into this architectural profile?
Absolutely, Mike. The SD-WAN based architecture, they started with application-based traffic steering, and they added that functionality which was missing in the router-based model. Initially, in the routers themselves, they essentially did add load balancing. They added visibility into it at the application layer, maybe application experience. But frankly, this was not designed with security in mind. It lacks advanced routing to essentially go into a legacy network and start performing seamlessly with the other set of branches which have not yet moved to SD-WAN. It lacks advanced security. And clearly, today there is no network worth having where security is not built into it from the ground up. And lastly, it lacks WAN optimization, which clearly would be needed for traffic going over intercontinental links in order to give excellent application user experience, Mike. So clearly, SD-WAN, they fulfill a particular gap there, but then they leave out all the other functionalities which are needed to seamlessly operate in today's branch.
Now, you've purposely not included the security appliance within this model, and I believe that the reason for that is because the security aspects have got to be a next-gen firewall. This can't just be a basic stateful firewall that's within the device. A next-gen firewall is what you're looking at there, and UTM and next-gen IPS. These are all really sophisticated security capabilities that the SD-WAN based architecture just doesn't include. Is that the rationale there?
Absolutely right. That's why I didn't add security for these folks. They do some simplistic set of, some of them just say IPsec as a security. Some of them have a simple layer 4 firewall. But really what you need is the whole defense in depth, right from next-gen firewall to antivirus to URL filtering to IPS, IDS to DNS security, you name it. There are so many. You need SSL proxy. This is not something which the SD-WAN vendors really know how to do or have done historically. Okay.
Okay, so now we talked about those first two architectures. Let's talk a bit about this third architecture you have, which is the WAN optimization-based architecture. So this is, the approach here is typically it's an architecture that was started as a WAN optimization device, and maybe the business actually saw the things pivoting towards SD-WAN, and they decided to actually begin to add on SD-WAN capabilities, or maybe even a feature set or a software module. Talk to us about how that architecture is different from these first two architectures we talked about.
Well, precisely, Mike. The WAN optimization-based architecture started with WAN optimization solution and expanded the solution with a separate independent software instance for SD-WAN. However, besides SD-WAN, they put it as first of all as a separate software instance. So now again the same inefficiencies, redo of the 60% of the work between the separate software instance of SD-WAN and the WAN optimization. And additionally, it does not have advanced routing to coexist in a complex branch topology. And of course, it doesn't have the whole advanced defense in depth security we talked about just now, right from, next-gen firewall to antivirus to IPS, IDS, URL filtering, name it, SSL proxy, proxy chaining. There's so many different cases and security technologies you need to have to make it a viable solution, Mike.
Okay, so that's great. So we talked about router-based architectures, SD-WAN-based architectures, WAN optimization-based architectures. The latest model that I've seen beginning to develop some more attention is this, what maybe is referred to as a firewall-based architecture, where maybe I have a firewall solution using software and hardware, and there's a recognition now that, wow, the firewall space is, really requires SD-WAN capabilities, especially for that part of the business to really grow and succeed. And so as a firewall, I need to actually bring in some SD-WAN functionality or capabilities, or maybe software, maybe even make an acquisition in that space. So what does that architecture? Because that's a very specific architecture. That's really a firewall that began as a firewall. There's a specific design and architecture required to be successful as a firewall. And now we're bringing, some of those architectures are looking at bringing in SD-WAN functionality or modules or things along those lines. So talk to us about that firewall-based architecture in the larger scheme of SD-WAN architectures.
I'm glad you talked about that too. Firewall-based architecture, Mike, started with a firewall solution, and now they've expanded that solution with SD-WAN, which typically runs as a separate independent software instance. However, again, this set of folks also do not solve the problem holistically and bring simplicity into the branch network. They lack the advanced routing to essentially coexist in a brownfield environment. They lack WAN optimization, and even their SD-WAN capabilities are very rudimentary and preliminary. So, just because somebody comes and says, hey, you know what, I have SD-WAN, doesn't mean that they have all the possible functionality related to the application user experience and the automation and the visibility which is needed in today's network, Mike.
Okay, so that's a great overview of the four types of architectures for SD-WAN. A question I have for all four of those is, certainly it's pretty obvious that these look like individual modules, either hardware or software modules that are brought together. But how would one manage each one of those four architectures as an example? Like what does that look like if I were to as an IT administrator, SecOps team, NetOps team, WAN op team, managing these things? What does that look like?
I mean, clearly, when you have to manage this, they may have a separate management system as far as each and every one of this functionality. Sometimes they may have a unified management layer, but underlying the technology is separate. And that brings us to the secure SD-WAN architecture. And Mike, the funny thing about secure SD-WAN architecture is all this capability and functions are designed into a single software stack from the beginning, and architected in such a manner that they will all operate together as a single software entity in a fully integrated software solution. Now, there'll be folks out there who will say, you know what, I like to have XYZ function as the best of breed and all that other stuff. By all means, even for the single comprehensive, fully integrated, secure SD-WAN solution, you want to look for a solution which offers the security which is top class, which offers you routing which is top class. So, we are not here in the business of saying, hey, you know what, Mike, let's be very good at SD-WAN, but not so good at other functions. When we talk about secure SD-WAN, it achieves excellence not only in SD-WAN, it achieves excellence in routing, and the same thing with security. And this security, Mike, is not, like you said, layer 4 security, but security which is being tested by independent labs like NSS, and have given huge, have recommended the security, and also put us as the top recommended security offer in combined with SD-WAN or without SD-WAN. So clearly it is achieving excellence on all those three fronts, routing, software, SD-WAN, as well as security, Mike.
Okay, so a secure SD-WAN architecture is an architecture that from the very beginning was designed and architected and built with all these capabilities. And what you're describing is really, it's got to be a best of breed security, advanced scalable routing, a full-featured SD-WAN, WAN optimization. There's certainly likely other capabilities, and I know we'll talk more about those, but all those things are designed from the very beginning with an architecture that doesn't require adding on SD-WAN or adding on security or adding on routing. There are actually things that are embedded and designed and architected into the solution from the beginning. So talk to us a bit more about what does that look like, as I deploy something like this, as I deploy a secure SD-WAN architecture. And we'd love to obviously learn more about an secure SD-WAN architecture model.
Yeah, so that brings us to the next slide. All those functions are essentially, like I said, packaged into a single software stack running on a single device, achieving excellence on all those parameters you just spoke about, whether it's SD-WAN, whether it's routing, whether it's security, WAN optimization. That is when you really achieve a solution which offers you simplicity as well as agility. So that is essentially what is important. Now here, what does this secure SD-WAN solution, where it is a single package, which is essentially giving you the combined solution gives you? It gives you one WAN device to manage. It gives you one management system to learn, no more of multiple management system to learn. It also is optimized for performance, and we'll get into that, why it is optimized for performance. We've eliminated all those 60% of the functions which you are redoing and doing for every one of those devices, for every one of those appliances. It gives you optimized performance for SaaS, and it gives you minimum resource skills needed to manage this network, and it's fast to change, as well as resilient to failure with full visibility. So that is what the solution should offer. And we'll get into a little bit more in detail in the next slides. But this is what really, this is what the corporations need to go from a very complex architecture to a single architecture which achieves excellence on multiple dimensions. Right?
So clearly a lot of significant advantages, but Kumar, you showed the flow of packets through traditional wide area network with SD-WAN, security WAN optimization, all these capabilities, and you showed a lot of redundancy and inefficiencies and performance impact and latency and even security vulnerabilities. How does this change with this model? Very good question, Mike. Let me go into the next slide and essentially answer your question fully. So first of all, as far as the inefficiencies is concerned, we'll just go through the packet path here and show you how the packet traverses through all the functions. Notice that all these functions like get packet, parse packet,
route lookup QoS, DPI, next-gen firewall, they are all done only once before the packet goes to the internet, okay? That's number one. Number two, you have only one code base to worry about in terms of security compliance, which is developed in a holistic manner with the ground up, especially with the perspective and a real vision thinking that no network is worth having where security is not built into it from the ground up. So frankly, a secure SD-WAN solution would have started out with security, understanding that no network is worth having without security, and then basically come up with a holistic design where you have in single pass, you are doing all these functions once and achieving performance, Mike. Okay, so
yeah, that makes
what does this,
sense.
Sure, and what does this result in for the end user? You can see the change from a complex architecture on the left, which probably sets you back the IT guy per branch at a cost of about $100,000 to a simple network with one software code which runs all those functions. Now again, you know, people would say, hey, you know, are this best of breed? Clearly, the answer is yes. We have achieved excellence in all of them. They are independently tested. They are independently deployed by large corporations where you essentially get a zero-touch one-box solution. This box costs, you know, less than $1,000. So you can see the amount of efficiencies you're getting from an architecture which is complex in nature to where you can be if you choose to be, Mike.
That makes complete sense. Now, that, you know, one of the things that does come to mind is that this is a fantastic model. Certainly, you know, convergence of best of breed across the board, integration within a single software stack. Clearly, plenty of benefits there and advantages, of course, over other architectures. But as I look at a solution, you know, times have really changed over the last 5 to 10 years, and now there's a lot of applications which run, for example, in the cloud. There's SaaS, there's cloud services, cloud storage, there's data as a service, all these solutions in the cloud. And I may actually have my own, you know, call it a private cloud where I'm hosting in a cloud instance that might be, I own it, maybe it's owned by somebody else, maybe it's co-located, or the public cloud. And then, of course, certainly within my own branch office or my own enterprise, I've got branch offices, I've got regional locations, distribution centers, warehouses, I've got campuses, I have private data centers, and now especially I've got home offices have become a huge prevalent component of my my enterprise network. When I look at this type of a secure SD-WAN architecture, is it an architecture, Kumar, that can be extended to all these locations? Does it actually expand pervasively across this and really give kind of an end-to-end, you know, model, consistent, pervasive model?
Absolutely, Mike. Let's go to the next slide. You know, this secure SD-WAN architecture, in our opinion, should be one software solution, which kind of deploys, which can be deployed in the branch office, can be deployed in the corporate headquarters, can be deployed in the data center, as well as you know, a lot of applications are moving to the public cloud. So, you know, it should be deployable in any public cloud you can think of today. Should be able to deploy itself in the private cloud, whether in the private cloud you have different virtualization technology or not. So, you know, clearly you want all of that functionality in your solution to support. And that takes us to the next slide, Mike, which kind of gives you the color on exactly how those functionalities are there in a very good secure SD-WAN architecture. So here you can see that a secure SD-WAN architecture can be deployed in Equinix, AWS, Azure, Google Cloud Platform, Alibaba, Tencent, supports a whole bunch of virtualization technology. You know, whether it is OpenStack, whether it's VMware, KVM, Microsoft, Xen, it should support all of this hypervisor technology. Additionally, it should be cloud native. It should be multi-service. It should be multi-tenant, Mike. And also, it should be an open platform where, for some reason, if the user is familiar with some technology, maybe they want to deploy their own favorite security vendor rather than the inbuilt security which we have, it should allow them to load that particular VM into the software. So all that is possible with a good secure SD-WAN architecture. And it should also allow them to run this thing on white box network appliance for today's disaggregated software architecture, as well as on any gray box or Versa appliance. As you can see, Mike, in the end, the customer should have a choice and should not be limited to, you have to use my proprietary appliances, or you have to use my software, or you cannot use security from another vendor. If you do, then it has to be on a separate in a separate appliance or something like that. Or let's say for a moment you want to add your own secret sauce. You may want to add your own software which looks at credit card processing. This sort of architecture should allow you to do that, and that is the key. The user should want that. Will the architecture give me choices? Will the architecture allow me to give me deployment choices also in different kind of deployment scenarios? And does it have a great inbuilt security? Does it allow me to mix and match vendors? All of that is possible in a secure SD-WAN architecture, Mike.
Okay, so this is great, Kumar. I love this. This kind of gives a sense of the, where a lot of the value is in the software, and this idea that it's flexible enough to run on all these different, platforms. One of the things that I think does come up in other architectures for SD-WAN is, quite frankly, often if it isn't part of the core competency of that particular architecture, it maybe is a second-class citizen. So, for example, integrating security as an SD-WAN vendor, maybe more of a pure play vendor, and bringing in security maybe isn't as much of a focus. Maybe it's a basic firewall that's brought in, for example. But really, what I've heard you describe is the secure SD-WAN architecture is one where all citizens are equal. The routing is as important as the SD-WAN, which is as important as the security capabilities, next-gen firewall. And so it's not just an architecture where those things are added as a capability, maybe more of a checkbox, some people might say, but these are actually individual capabilities, functions, and services that are constantly evolving and being developed and really best of breed across the board. Does that sound right? And can you talk a little bit more about maybe some of the details of what are the capabilities of functions one might expect to see within a secure SD-WAN architecture, expect to find?
Very good segue into this next slide, Mike. Clearly, first of all, I totally agree with you that routing, security, and SD-WAN should be equal citizen, should have achieved excellence. The secure SD-WAN architecture achieves excellence in all three of this, and I'll get into why they are needed. For example, first of all, the whole idea is to eliminate the appliance sprawl, and that is why you really need a secure SD-WAN architecture which combines routing, networking, security, SD-WAN, Wi-Fi, LTE. Additionally, it should allow you choices. It should allow you choices for third-party VNFs. It should allow you flexible site configuration with multiple WAN types. It should be easily, and the reason you need to achieve excellence in routing, Mike, is because you want it to be easily inserted into existing network. You want it to essentially provide you underlay and overlay connectivity at the same time. And you want it to allow you seamless connectivity across multiple MPLS managed and SD-WAN nodes. And you want, on the SD-WAN side, you want, visibility and control of application. You want SaaS optimization. You want contextual visibility at user, device, application flow, and network level. And you essentially definitely want a single pane of glass for all of that. Now, if you look at it, on the security side, all these black blocks are the defense in-depth security, which a secure SD-WAN architecture would have, whether it's next-gen firewall, whether it's URL filtering, whether it's IPS, IDS, whether it's malware detection, whether it's whether it's data loss prevention, whether it's antivirus, DNS proxy, proxy chaining, you name it. There are so many things which essentially you need to achieve excellence in security. And a secure SD-WAN architecture definitely achieves excellence by making sure all those defense in-depth blocks are implemented, Mike.
Kumar, you mentioned something really that just caught my ear as you were discussing all the functionality and capabilities of a secure SD-WAN architecture, many of them. And that was around routing and the importance of routing, which struck me because I've come to realize that there's really almost never a greenfield implementation. I mean, they do happen, but it's almost always a brownfield model. What I mean by that, Kumar, is that there's almost always some existing infrastructure, networking, products, whether they're routers, security devices, even WAN optimization that's still within the network. And so it always feels like there's some level, if I could, as an enterprise, have integration with that existing network, that would be something that's beneficial to me. And really integrating with that underlay, along with providing the overlay in a completely integrated manner. Does that align with what you've seen? And certainly you've been doing this for some time with customers and clients that you've seen.
Yeah, I mean, I think a secure SD-WAN architecture, Mike, at the end of the day, should be able to coexist in any network which is out there. And frankly, should support both the underlay technologies as well as the overlay technology with full flexibility, okay? For some reason, let's say if the overlay technology is not working, you should be able to fail over to underlay technology easily. So, it is, it is something which is very important to achieve excellence in routing, also to have a seamless movement from branches which are managed by, let's say, MPLS VPN technology or VPLS technology to SD-WAN. So clearly, that is extremely important, Mike. Both the support of underlay and overlay is very important for coexistence in the brownfield environment, not only for coexistence, but to also move slowly every branch from one technology to the other, Mike.
And then one last thing that just also jumps out at me, and especially since over the last several years, this has become, I would say a term that has come up very often and is defined in different ways by different people. But this idea of multi-tenancy, and I've noticed here with this model, this architecture, you're showing multi-tenancy really across everything. And I know certainly multi-tenancy is a key for carriers, telcos, operators, service providers, but also a lot of large enterprises operate their business where they need, full multi-tenancy, for security reasons, for persona and roles, for cost reasons, to be able to drive down costs, for functions, all these different things. So can you talk just a bit more about what you mean by multi-tenancy across all these different capabilities within a secure SD-WAN architecture?
Absolutely. I'll give you a couple examples, where multi-tenancy is quite useful, even in the enterprise scenario. And actually, there are so many examples. I'll give you a couple of them. One is, let's say you you have a bank, okay, and it wants to have one tenant for retail, another tenant as they want to have one full segment for retail customers, another one for another retail division, another one for investment division, third one for guest Wi-Fi. And all of this can be tenant by themselves, and each tenant can have multiple VRFs. Additionally, each of this tenant, Mike, can have their own separate topology. One can have hub and spoke, the other can have fully mesh, third can have partial mesh, you name it, okay? They can have their own separate policy. Now, in our architecture, multi-tenancy is not simple thing like, okay, separate VRF for separate tenant. It is separate control plane, data plane, and management plane. And that is what real multi-tenancy is all about, okay? And for every one of those tenant, Mike, you can have multiple VRFs. So clearly that is just one example. There are other examples where you could be a company which has acquired other companies, and now you want to manage them as one network, but you want to manage them as separate tenants underneath a bigger headquarter-based IT department. So, that is also possible, okay? Additionally, what happens is multi-tenancy is different from RBAC. For each tenant, we support RBAC. That means what happens is a secure SD-WAN architecture, the network person will only be able to change network-related stuff. The security person will only be able to configure, monitor security-related related items. So all that has to be possible through RBAC. You have a network role, you have a security role, you may have an operator role, you name it. All that the software should allow you to do. So clearly, you need multi-tenancy and RBAC not only in service provider world, but even in large enterprises, especially the global 2000s. Mike.
Yeah, that's a great review.
Yeah, another thing, Mike, I wanted to bring up is also, you really need, at the end of the day, also high availability, high availability at the branch, at the data center, at the headquarters. And all that, once you support security, you want high availability where it is stateful, not stateless, okay? So all those things have to be thought out well in a secure SD-WAN architecture, Mike.
That makes complete sense. Now, so really what you're describing, I would almost call it genuine multi-tenancy across all these functions and the entire system, end to end, and that makes a lot of sense. So I think what's really interesting now is if you could talk a bit about, certainly you've talked a lot about a secure SD-WAN architecture and, the premise of the software and the, single comprehensive integrated software stack. But there's also aspects of the underlying hardware which can really be, drawn out through an architecture like this. Is that something that you can talk a little bit more about?
Absolutely. A lot of folks may say, you have so many functions, is this box does this architecture will be able to keep up with the throughput? The answer is yes. In today's world, you can have multi-core CPUs with 2-core, 4-core, 8-core, 16-core, 32-core, 54-core, you name it, So depending on the type of work you want the cores to do, depending on the type of duties you want the cores to do, you can scale the number of cores very easily. But clearly, your software has to be multi-core and multi-threaded capable. Now, in this particular diagram, it shows you how the division of duty happens. The polar CPUs or polar cores, they essentially, their job is to essentially bring the packet from the network, and then they're like managers, They delegate work to the worker CPUs, who after they finish the work, they give it back to the polar CPUs to be sent out. And each of this, we'll zoom into this one slice like this and show you how it is done, Mike. But this is all related to the performance you need. The architecture is the architecture will give you the performance you need, provided it's multi-core, multi-threaded, and on the Intel architecture, it supports DPDK interface, okay? Because you don't want a lot of copying which happens and context switching which happens to the kernel. It has to bypass the kernel to give you the maximum performance. It has to be, the software has to be developed with the parallelism and concurrency built into it to achieve high performance. So we're going to go into one of these slides here and show you how it happens quickly. Let me go to the next slide here, Mike. So this just goes from polar to worker, so you got one flow which is given to one worker CPU. You get second flow which is given to the second worker CPU. A third flow comes, it gives third for worker CPU. So this essentially, this polar CPU's job is to get the packet from the network and be like a manager to delegate work to all these worker CPUs. And those worker CPUs are working parallelly. You know, it's like as if four mics are working together on getting the work done. So clearly, it's a huge performance gain by using all these multi-core CPUs and also multi-threading in the architecture. So we are going to now zero into, I'm going to go back here, and what we are doing now is zeroing into one of the worker CPU and what happens in the worker CPU. So let me go to the next slide quickly. So there you go. So what we have again is a single pass parallel processing architecture where you have all these functions. And by the way, this is a very simplistic view of how packet processing happens across different modules, where all the stuff which we talked about, the getting the packet from the wire, parsing the packet is only done once. And then there is, and then what happens is that the first packet is sent to these modules, which essentially kind of tells us whether they have interest or they don't have interest in the packet, depending on the configuration. After that, the packet goes through only those modules which essentially have exhibited interest. Like in this case, let's say quality of service or routing or DPI, just an example thing, you know, it just jumps to those modules and doesn't bother with the other modules and gets out. So this is just one example. Another packet comes up and all it wants to do, another flow comes up, all it wants to do is essentially routing, SD-Wan, user authentication, and URL filtering. Then only those modules are asked to work on the packet. So you can see, you know, this is a very simplistic way of showing it, but clearly there are a lot of efficiencies even in this architecture we brought to achieve highest performance you can get on a multi-core CPU with single pass parallel processing architecture, Mike. I think with that, I am done with my slides, Mike.
Yeah, that sounds good.
In case you have any questions. Okay.
Yeah, that sounds great. So I guess one thing that jumps out at me here, going through that sequence, is really a couple of things. One is that it feels like it feels like a very elastic, scalable, you know, economies of scale model where there's the single software stack, but as I add more processing underneath and more cores, it just magnifies and amplifies the performance and the power of that system, which I think is very interesting and certainly something, you know, it's almost like the cloud type model, where as you add more compute, you get more performance and more scale and all those things. And then the second thing, Kumar, is the last couple of foils that you went through remind me, you know, having a hardware engineering background myself, it reminds me a lot of a pipelining model within an ASIC. And ASICs have to be designed with incredible performance and tight tolerances and have to be optimized and maximized for performance. And this model feels a lot like that, but it's being done in software and taking advantage of, course, hardware. But so those are the two things that jump out at me with this.
Absolutely, Mike. I'm really glad. I think that is definitely a similarity there of a pipeline model which you would see in an ASIC. Essentially, you know, in reality, what happens is that the packet never goes from one module to the other module. The packet goes to the packet buffer, and then a pointer is passed around to all this module to express interest. And in the first packet, and only those modules which express interest get the subsequent packets of the flow. At any point, a module can say, I don't want to see any more packets of the flow. For certain kind of work item, we don't even have to send subsequent packet to those modules, because essentially what happens is that they create some metadata, and we just look up that metadata in a cache and move the other packets around. Send the subsequent packet onto the wire quickly without having to send to the pipeline, the pipeline itself. So I think going back to what you just said, yes, it is very similar to the ASIC pipeline architecture, but the slide itself is a very simplistic view. There are a lot of efficiencies in a parallel processing architecture which we have brought to make it highly efficient in terms of achieving the maximum performance, Mike.
Okay, this is great. Thank you very much, Kumar. And so we have a tremendous number of questions that have come in, and we're not going to be able to answer all of them, but the ones that we don't, we will follow up with an email, to them. And if you have questions, please answer those now. So Kumar, I'm going to just go through some of these. We'll try to go as quickly as possible. So one question is, in a DMZ zone, many companies use a firewall from two different manufacturers as a best security practice. And so I think what maybe the question there is, this secure SD-Wan model architecture, you could actually run the firewall that's integrated within the device, but you can also have a separate firewall running also, or you could actually do kind of both of the same or whatever model you'd like. Is there anything quickly you touch on that at all, Kumar?
Absolutely right. I think you can have, and I think that's one of the good thing essentially people do is in the DMZ zone, they have one vendor or the other vendor. So what happens is that as essentially they do get some more defense there, and also the same software code is not running on both of them. So the same vulnerabilities or whatever it is not exploited on both of them. So clearly, we support that architecture fully. You can use our own built-in security as one of them, and you can make it coexist with another vendor's firewall in the DMZ zone, or you can have both of them as us. You can have, like I said, we support redundancy itself also on our security. It's the stateful security redundancy, or you can mix and match with you can have the same kind of architecture which the question asked. Have a multi-vendor architecture. We will coexist in the secure. Such architectures, definitely we've seen it. We worked in it, so that should not be a problem.
Excellent. So there's also a couple of questions on UTM, Universal Threat Management, and maybe just quickly touch on these. So one question is around, and these are, I think, a little more specific to, Versa. So Versa is, does have a secure SD-WAN architecture. But the first question is around what type of performance, did you see any performance degradation or throughput impact with security added, such as like a fully loaded Universal Threat Management, functions, and then the other question here is, can you compare Versa Universal Threat Management versus third-party Universal Threat Management functions in terms of things like performance and throughput? I know there's some good data on that specific to Versa, but is there anything you'd quickly touch on there?
Totally right. Totally right, Mike. All good questions there. First of all, one of the reasons why we went into parallel processing single pass architecture is clearly as far as on the security side, as far as next gen firewall is concerned, there is no real performance impact at all. There is going to be some performance impact with antivirus and IPS IDS, And that's true with all the vendors, by the way, not just us, okay? However, as long as you have more cores and you have a multi-core, multi-thread architecture and you size it properly, you should be able to handle all the branch bandwidth or headquarter or data center bandwidth that is needed to support the UTM functionality. As far as our UTM functionality itself, Mike, I suggest the user to go to NSS Labs in Austin and get the UTM report. They do public test on all the vendors, and the last public test was done not too long ago, probably maybe 3-4 months ago, when they ranked us above all the other security, most of the other security, mainstream security vendors in terms of both performance and TCO and security effectiveness, all three of them.
Okay.
So I'd suggest the user to look at it, and those details are very, those reports have a huge amount of detail on how they tested it, and I suggest that they look at that. Nothing we'll say in this 5 minutes, a few minutes, will get into that kind of detail.
Fantastic. So switching gears here, there's another question about being able to optimize back into SaaS applications and Office 365, things like that. How is that done? You talked about the cloud implementation and implementations in the branch and campus and data centers and all those areas. How does the optimization, SD-Wan functionality, security, how do all those things operate for SaaS applications and like Office 365 in this example?
Yes, absolutely right. So first of all, Mike, we are partners with Microsoft, specifically with 365 and SharePoint and all of that. And we have implemented specific functionality in conjunction with Microsoft to make sure we give them. We essentially follow the guidance which Microsoft has given us and by the way, that's all implemented in shipping code to give the best application user experience for Microsoft 365. So that's one thing. Second thing, as far as the other SaaS applications, you can have a direct connect gateway in Equinix, which essentially which will straight away take you to many of the SaaS application providers, and you will have one of that branch in the direct connect in Equinix. Through our APIs, you will deploy one of the branch in Equinix, and that gives you direct connect to all the SaaS applications. Third is we look at passive way of figuring out which particular link gives you the best SaaS application throughput. That's a patented way of doing it. We've done that. We come up with application link score, and based on that, we know which particular link to send to get the best SaaS application experience. And the other one is the active one. So, I just went over 4 ways of getting the best SaaS application experience for you. It depends on whether you want to use multiple ways, you want to use one or the other way. It's up to the user. For Microsoft 365, I suggest just use our Microsoft 365 technology to get the best application user experience. For others, use Equinix, and if the Equinix doesn't support direct connect to some of the other SaaS applications, then use our active and passive mechanism to get the best SaaS application user experience, Mike.
Fantastic. So quite a few other questions. We will respond to these in email. Also, there are a number of questions on analytics and visibility. We'll run a separate deep dive webinar on that. There's some questions on routing and WAN links. We'll run another deep dive session on that. We'll also do a deep dive session on SD-WAN and capabilities there. So again, I'd like to remind everybody this webinar has been recorded. It's available immediately following this broadcast on demand. The slides from this webinar are available right now or on demand by clicking the download attachments tab. We thank you very much for joining us today. And Kumar, this has been a fantastic educational experience for me, and I appreciate you joining and leading the webinar today.
Yeah, and I also want to thank all the folks who take the time out and join the webinar. Please be on the lookout of other webinars from us. I think we have another 22, 23 of them coming up. Each of them are going to be informational and educational, and it'll be all worth your time. Thank you very much for joining.